Good morning everyone. Now see the theorem number 25 on page 44 of chapter 1, theory of divisibility, number theory. Yes, number theory, page 44. Theorem 25. Yes, what is this statement of theorem? There are an infinite number of primes. Yes, there are infinite number of primes. This is we have to prove. Very easy. Always there I have told you which are the two methods to go for theorems. One is induction and another is by contradiction. Yes, so go by contradiction. There are infinite number of primes, so assume there are finite number of primes and proved, we get contradiction. Yes, so proof is very easy. So this theorem was proved by Euclid. Yes, Euclid proved this theorem by contradiction. Yes, by contradiction. Very easy proof. Assume, we have to go by contradiction. Yes, assume the contrary. What contrary? That the number of primes is finite. The number of primes are finite. Okay, let the complete list of the primes be P1 is equal to 2, P2 is equal to 3, P3 is equal to 5, P4 is equal to 7, P5 is equal to 11, and there is one prime Pn. Yes, that is, there are n prime numbers only. Means what? We can count these n prime numbers. Yes, but what is statement said? Statement says us we cannot count number of primes. Yes, they are infinite, but we are assuming they are finite. So finite means we know what is the value of n. Okay, understood? Define m is equal to, yes, m is any integer greater than 1. So define m. Greater than 1 means what? 1 plus something. Yes, m is greater than 1 means what? Always in all this proof take m that is greater than 1. So m is any number which is greater than 1. So means 1 plus something. So take something quantity as P1, P2, Pn. Call this as equation 1. Okay, now n is, I have told you what? M is a positive integer greater than 1. Hence, by previous theorem, I have told you previous theorem. What? Previous theorem, that is theorem number 24. Okay, what is theorem number 24? By theorem number 24. M has at least one positive prime divisor. Yes, M has at least one positive prime divisor. Say P, that is P divides M. Since P1, P2, Pn exhaust the list of all primes. Yes, all primes. Okay, means what? M has at least one positive prime divisor. हे मागच्या थेरमनुसार आपण बघितलं, थेरम नंबर 24, याच्या आधीचा थेरम. ठीक आहे. M has at least one positive prime divisor P. M, we can write M is equal to P into something. So means what? P divides M. Yes, आणि आपण तर सगळी लिस्ट काउंट केलेली आहे. P1, P2, P3, Pn पर्यंत. म्हणजे हा P कोणामधला असला पाहिजे? P बिलॉंग्स टू या सेटमधला हा एक P असला पाहिजे. म्हणजे तो एक तर P1 असेल, P2 असेल, नाहीतर Pn असेल. ओके, सो दिस इम्प्लाइज व्हॉट? याच्यापैकी एक असेल म्हणजे काय? P हा यांच्या प्रोडक्टला डिवाइड करणार. येस, सो दिस इम्प्लाइज P जर यांच्या प्रोडक्टला डिवाइड करणार तर याच्या लिनियर कॉम्बिनेशनला पण डिवाइड करणार, असं आपण एका थेरम बाय थेरमने एका बघितलेलं आहे. दॅट इज थेरम नंबर 2 इन दिस बुक. येस, थेरम नंबर 2. सो व्हॉट इज? वी कॅन राईट M minus P1, P2 up to Pn. Yes, so this implies P divides, आणि from equation 1 P1, P2, Pn ची व्हॅल्यू काय असणार आहे? M minus 1 ची व्हॅल्यू काय असणार आहे? M minus P1, P2, Pn. So instead of this quantity we can write here 1. Okay, by equation 1, call this as equation 2. Everyone understood? See, yes, so P divides 1, but here we can write what? But 1 has only one positive divisor. 1 has only one positive divisor, that is 1 itself. Yes, 1 itself. And what we are assuming? See, 1 has only one positive divisor, 1 itself, since P greater than 1. Yes, so 8.2 equation 2 contradicts this fact. Yes, we have taken P greater than 1, but here we are showing that P divides 1. So this contradicts our fact. Hence the initial assumption that the number of primes is finite must be wrong. Yes, must be wrong, and hence there are an infinite number of primes, and hence there are infinite number of primes. Yes, and here we have completed our proof. Very important theorem. I think this theorem will ask in exam. Okay, thank you.